2.8 function operations and compositions. The first thing is the operations, and the operations are very easy because it is what you are used to, the adding, subtracting, multiplying, and dividing. So the definition is straightforward. If you have two functions f and g, then the function f plus g of x is found by adding f of x plus g of x. Just like two numbers, think of it. If you add a real number 2 to a real number 3, you get a real number, which is 5. So this is the same idea. Again, for the subtraction, multiplication, division. Okay, so you read that. And then the domain of the first three is the intersection of the domain of f and g. The intersection is what's in common between the two. So let us see example 1. We have f of x is 2x squared plus minus 1 and g of x is 3x minus 4, and we need to evaluate f plus g of 0. By definition, this is none other than f of 0 plus g of 0, and this is equal to f of 0 is negative 1, g of 0 when x is 0 is negative 4, and that will give you negative 5. As simple as that. F minus g of negative 1 is by definition is f of negative 1 minus g of negative 1. F of negative 1 is 2 times negative 1 squared minus 1, and minus g of negative 1 is 3 times negative 1 minus 4. I decided to show the more detail here. So negative 1 squared is 1, 2 minus 1 is 1, minus 3 times negative 1 is negative 3, minus 4 is negative 7. Then the opposite of that is positive 7, so that will be 8. So that's the value of this function, the f minus g of negative 1. How about the product? This is by definition is f of negative 2 multiplied by g of negative 2. What is f of negative 2? That is 2 times negative 2 squared minus 1 multiplied by g of negative 2, which is 3 times negative 2 minus 4. So this is 2 times 4, which is 8 minus 1, multiplied by, this is negative 6 minus 4 is negative 10. So this is 7 times negative 10, which is negative 70. F divided by g of 0 is f of 0 divided by g of 0. F of 0 is negative 1, g of 0 is negative 4, so that's always, it's easy, just like a, when it is 0, you get 1/4. Now let us find the function, those functions, not evaluating them, just finding f plus g of x and all that, f minus g of x. Example 2, let f of x be 5x minus 3, g of x be the square root of 2x plus 2, and let us find the following. F plus g of x by definition is f of x plus g of x, which is 5x minus 3, that's your f of x, add to it g of x. Look at this, we cannot add, there's no like terms, so we're done. Okay, f of x minus g of x, and that is 5x minus 3 minus the square root of 2x plus 2. Again, for this example, there are no like terms. F times g of x is the product. Since it's f of x times g of x, you be careful to put the parentheses around the functions. But again, we cannot do anything, so that's a nice and simple example. Division. So that is 5x minus 3 divided by the square root of 2x plus 2. Okay, but now, so this was really simple. Now we need to find the domain of all these. And by definition, the domain of A, B, and C is the intersection of the domain of F and the domain of G. So now, what is the domain of f of x? Well, that's a linear function. We know the domain of f of x is all real numbers. Now the domain of g of x, remember how we find the domain when we have a square root. Everything inside the square root has to be positive, because we cannot take the square root of a negative number. Solve this inequality. 2x is greater than or equal to negative 2. Divide by 2 to get x is greater than or equal to negative 1. So that is from negative 1 to infinity. Now, what is the intersection? If one of them is all real numbers and the other one is from negative 1 to infinity, well, the intersection is what's in common? What's in common is only the negative 1 to infinity. So intersection is from negative 1 to infinity. And that is the domain of part A, part B, and part C. But now, for part D, we have to worry about the domain is cannot be 0. When is the domain is 0? Well, we just solved this inequality, made it greater than or equal to 0. So all there is that it cannot be 0. So the domain for D is open negative 1 to infinity. Okay? Okay, I did not write. The domain is negative 1 to infinity, and for D is the open negative 1 to infinity.